The last video and the last thing we need to talk about with radicals is rationalizing denominators. And you may have touched on this in Algebra 1, but it's probably been a while. When dealing with fractions, we prefer to think of fractions as pieces of a whole number, which is why we typically don't have fractions inside of fractions or like decimals in our fractions, because we're not dealing with whole numbers. This leads us to the process of rationalizing a denominator. If you look at this, 3 root 2, or 3 over root 2, the square root of 2 is not a whole number. And so it's not written in a way that we really typically like to think of our fractions. So we can basically kind of mathematically rearrange the numbers to make it look like fractions how we prefer to see them. The process is pretty straightforward. You take your radical on the bottom, and because this is a fraction, you are allowed to multiply the numerator and denominator by the same number. Now doing this allows some magic to happen, really. We have 3 times radical 2, which is just 3 radical 2 on the top. On the bottom, we have radical 2 times radical 2, which is radical 4. Now, radical 4 is something special. Radical 4, the square root of 4, is 2. So these 3 over root 2 and 3 root 2 over 2 are equivalent fractions. But this one is written in a form that mathematicians prefer to see, and is a little bit easier for us to estimate without the use of a calculator. Let's do another one. There's a couple different ways that you can approach this. You can certainly rationalize your denominator right now. Since you see root 8 on the bottom of the fraction, you can multiply the numerator and denominator by the square root of 8. So right now we have 6 root 8 when you multiply the top. And then across the bottom, you have this 8 times 8, which is 64. Now conveniently, the square root of 8, or the square root of 64, is 8. And these are equivalent fractions. However, this fraction, unlike the fraction above it, can be reduced. It can be reduced in a couple different ways. Radical 8 can be reduced. So maybe we should start there. Let's come over here off to the side. Radical 8 is the square root of 4 times the square root of 2, which is just 2 root 2. So I'll replace that. I have 6 times 2 root 2 over 8. And I can do 6 times 2, which is 12 root 2 over 8. And this brings up an interesting point. The fraction itself here can also reduce. So we're kind of reducing in 2 different ways. If you look at just the whole numbers, 12 over 8, that fraction reduces because they're both divisible by 4. This is now 3 root 2 over 2. It's actually the same as the problem above it. How crazy. Now this brings up an important point that you might want to make a note of. You cannot reduce like the radical 2 and the whole number of 8. They're not the same type of number. So if you have whole numbers that are in common, you can reduce the whole numbers. If you have radicals that are in common, you can reduce the radicals, but you can't mix and match. You can't somehow make this 2 somehow reduce that 8. It doesn't work like that. So this is your answer. Let's do another one. You can kind of save yourself a little bit of reducing time and energy. Like this problem was a lot of steps. We got to here, and then we did this, and then we went through and we did this and this and this. Well, if you reduce your radical first, you might save yourself a little bit of heartache. So this is radical 20, which is the square root of 4 times 5, which is the square root of 4 times the square root of 5, which is 2 root 5. So these are equivalent. Now, when you rationalize your denominator, because you have to, first, these 5s don't cancel. This 5 cannot cancel out that 5 because this is a radical and this number in the numerator is not. So you can't try to cancel there. That would be illegal. But now, when you try to rationalize your denominator, you only really have to multiply by root 5 instead of root 20. So it's going to save you a little bit of calculations and computations. So I have 5 root 5 on the top, and then the 2 is still there. It doesn't disappear. 2 root 25 on the bottom. And then I have 5 root 5 times, or over 2 times root 25, which is 5. So it's 5 root 5 over 10, which, if you look at your whole numbers here, the 5 and the 10, 5 over 10 is just 1/2, or since we have the root 5, it's root 5 over 2. Let's look at one more example. So when we're doing this, there's a couple different ways we can think of it. This is a fraction underneath a big giant square root. This square root is the same as saying root 20 over root 32. And there's a couple different things you could do here. I would reduce now before trying to rationalize, because then you're going to end up having to multiply 20 times 32 and then trying to reduce that radical, which is not fun. But before you do anything, before you even reduce the radicals, we can actually make these numbers smaller, because this is 20 over 32, or root 20 over root 32. So I can actually say, let's see, they're both 20 and 32 are both divisible by 4. So this would be 5 root 5, still going to have a root, over root 8. So right now the numbers are even simpler. And then I can reduce even further. I can reduce radical 8, which I already did previously in this video. But let's do it one more time, just for good practice. I'll come down to the bottom over here. So radical 8 is radical 4 times radical 2, which is 2 root 2. So now I am at radical 5 over 2 root 2. By doing this, I now make the problem simpler. I don't have to multiply top and the bottom by root 32. I can just multiply it by 2, which is very straightforward. So I have on the top of my fraction root 5 times root 2, which is root 10. And then in the denominator of my fraction, I have 2 times root 4, which is 2 times 2, which is 4. And again, root 10 over root 4 does not reduce, because 4 is a whole number and root 10 is not. But this is equivalent to what I started off with in the beginning, and is a lot simpler and easier to work with, and easy for us as mathematicians to approximate. Feel free to review this video again. Please work on your assignment, and as always, ask me questions if you need to. Make good choices.